And now let's do our balancing. So just as we did the before, where we were balancing equation where we knew the fuel, we're going to do it the same way. So I'll do a carbon balance, and I have X here, and I have equals 12.5 plus 0.3 is equal to 12.8. I'll do an N, if I look at N2, I know N2, I have 3.76 C is equal to 84.1. Therefore, C is equal to 22.36. And so the nitrogen always is in this ratio in the air, and with that I can find C, and that gives me O2 as well. So O2, so now O2 is a little more complicated. Let me do H2 first. So we'll do H2, and on the left side we have Y, and on the right side we have 2E. Oops. So now I see I have a problem here. So let's see what happens here. I know the oxygen that's being provided. So here I know the oxygen that's being provided, and I know how it's being consumed. Oh, and here's a way for me to find E. So if I do the O2, I have 22.36 equals 12.5 plus 0.3 divided by 2 plus 3.1 plus E divided by 2. And with this, we get E is equal to 13.2, and therefore Y is equal to 26.4. And so the hydrocarbon is C 12.8 H 26.4. And so obviously this is a blend of hydrocarbons. It isn't just one hydrocarbon. And so now let's find the percent theoretical error. So this was, we had this equation. So we balanced this equation. So now we have this equation balanced. And now let's do this for 100% theoretical error. So we have C12H 26.4 plus O2 plus A times O2 plus 3.76 N2 yields 12 CO2. So this is for 100% complete combustion, so we don't have any CO around, plus 13.2 H2O, plus we're going to have some N2 left over, but we're not going to have any O2. So if I look at this, then A is equal to 12 plus 13.2 over 2 is equal to 19.4. So I have here A is 19.4. If we went back to the original, so we did the original CXHY, the A value, A was equal to 22.36. So we found what that was. That was when I balanced the equation and I found out what this was. The number here, which let me just double check and make sure that I use the symbology. No, I use C. So I had C. Was that? So whatever this was, the moles of air, moles of O2 and N2. So that was preceding. So it's the same numbers here. So now if I look at the air-fuel ratio, the percent theoretical error, I take the 22.36, the amount actually used, divided by 19.4, the amount, the theoretical minimum, and we have this is 115% theoretical error. So what we do is we calculate it for the actual conditions, then we look to see what the ideal conditions would be and look at the difference between the ratios, and I don't need to bother switching it over to the mass basis because the mass numbers cancel out. Now for homework, so I'm not the only one doing these problems, 12.1, 12.3, 12.9, 12.13, 12.25. So what we've looked at so far is conservation of mass. So we've done conservation of mass, but something about this course had to do with energy. And so now let's look at an energy analysis and begin to do that.